So our discussion today focuses on oxygen gas, that is the preparation of oxygen gas. So you need to know two ways of preparing oxygen: the laboratory way of preparing oxygen and also the industrial way of preparing oxygen. But of course you need to remember that oxygen gas is always diatomic. What do I mean when I say diatomic? Well, that word diatomic simply means two atoms combined. So there are two atoms that have actually been combined. It is diatomic. Now, in the composition of air, you find that the percentage of oxygen in air is simply 21. It is simply 21% by volume in air. So that is the percentage of oxygen. So now let's go deeper and look at the preparation of oxygen. So we are going to start with laboratory. So we can talk about laboratory preparation. So laboratory preparation of oxygen. So how is oxygen prepared in the laboratory? So that is what we want to focus on. So there are some chemicals that can be used in the lab, or that we use in the lab to prepare oxygen. So let me say maybe chemicals used in the lab in order to prepare oxygen. So one, it is possible that you can use sodium nitrate. Sometimes we use sodium nitrate. You can also use potassium nitrate. It is also possible, a decomposition of that. I will talk about it very shortly in brief. So potassium nitrate. So these are two chemicals that you can use in the laboratory. I will talk about them and how you can prepare oxygen by using sodium nitrate as well as potassium nitrate. Another chemical that you are able to use in the laboratory is potassium chlorate. So you can also use potassium chlorate, normally thermal decomposition of potassium chloride. But don't worry, I'm going to show you how you can go about that. Then the other one that we normally use is hydrogen peroxide. So we use hydrogen peroxide, H2O2. So that is hydrogen peroxide. So these are chemicals that we normally use in the laboratory when you are preparing oxygen gas. Let's start with when you are using sodium nitrate. So when you are using sodium nitrate and potassium nitrate, what do you need to do in order for you to obtain oxygen? Well, it is very simple when you're using that. So what happens is that when sodium nitrate is strongly heated, you are going to find that what will be produced, the gas that is going to be liberated, is oxygen. So in the lab, you need to strongly heat strongly sodium nitrate or potassium nitrate. So you can heat them strongly. So what is going to happen is that if you look at the overall reaction, when sodium nitrate in solid form is actually heated, it is going to produce sodium nitrite. So that is going to be produced sodium nitrite, plus oxygen is going to be liberated. So sodium nitrite is going to be produced and oxygen gas is also going to be liberated. So that will still be in solid form and that is going to be in gaseous form. But you can balance up that by putting up, in this case, a 2 there. You can also put up a 2 there. So when you put up a 2, remember there are 2 times 2, that's 4, plus this 2, that gives you 6 oxygen. So 2 times 3, that gives you again 6 oxygen. There are 2 sodium, the equation is balanced. 2 nitrogen there. In the other one, if you are using potassium nitrate, again, when you strongly heat potassium nitrate, this potassium nitrate is going to produce potassium nitrite, which is in solid form, plus oxygen again is going to be reballated. They're in the same group, therefore balancing them up is just in the same way. So that is the way you can prepare oxygen, in the laboratory by using these two chemicals, sodium nitrate and potassium nitrate. What about when it comes to using the second one? We are calling as being hydrogen, peroxide. So how can you use hydrogen peroxide? Let me start, or I can start with the second one that I just highlighted by using potassium chloride. So remember, potassium chloride is LCO3. So what do we need to do when we are using potassium chloride? It is very simple. What happens is that the potassium chloride is mixed with a catalyst. So you're going to mix it with a catalyst known as manganese 4 oxide. Upon heating, it is going to decompose into potassium chloride and oxygen. So I can say that potassium chloride is treated with a catalyst which we use manganese 4 oxide. So that is the name of the catalyst that we use, manganese 4 oxide. So upon heating, you are going to find that oxygen is also going to be produced. Remember, the potassium, the manganese 4 oxide, acts as a catalyst, helping potassium, to decompose the potassium, chloride. That should be potassium chloride into potassium chloride and oxygen. So the overall reaction is going to be like this, potassium perchlorate, which is in solid form, when it is heated in the presence of the catalyst. Remember, a catalyst only speeds up the rate of your chemical reaction, but at the end of it, it remains unchanged. You are going to find that you produce potassium chloride, which is still in solid form, and oxygen gas is going to be reballated. You can balance up the whole equation. We can put up a 2 there, a 2 there. We can also put up a 3 there, then the whole equation is balanced. So this is what is done when you want to prepare oxygen using potassium chloride. Now in the exam, most often you are going to find the apparatus that we can use when we are preparing potassium chloride. So what we can simply do, we can have our trough, our gas jar as well. Let me just try to put up an arrangement there. I'm sure you still remember when I talked about preparation of gases. Hopefully you checked out that video, so you're going to see what you need to do in collecting different particular gases that we do have. So this is representing a gas jar. This is a water trough. Let me just represent it like that. So this is a water trough that you're going to use. So water can be in there, and so water can actually be in there. Then we can have our sort of test tube. Let me just try to extend it. So basically this is the arrangement that you are going to have there. So inside you can use your potassium chloride, and you can use the manganese oxide. So let me say we can have some lumps then inside there. So the lumps there, the bigger ones there, are representing potassium chloride. So that is potassium chloride, and of course maybe the liquid there is what we are calling as being manganese. So that is manganese 4 oxide. So that is manganese 4 oxide. Remember, the formula for manganese 4 oxide is actually this one that I've written there. So that is what is going to be happening. Now overall, what is going to happen is that, remember we did say you need to subject this to heat. So somewhere here you need to supply the heat. So it is going to be heated. So we can say the heat source. So you're going to have the heat source. So when the potassium, the chlorate, in the presence of a catalyst we are calling as being manganese 4 oxide, is going to produce, oxygen. And that oxygen, when bubbled through, it will bubble through the water and it is going to be collected there. So you're going to have oxygen gas being collected there. Now, why is the oxygen going to be collected in such a fashion? Remember, oxygen is slightly soluble, so therefore it is possible that you are able, to collect it, up there. And then, of course, another property that you need to remember about oxygen is that actually this oxygen is slightly, of course it is slightly denser than air, but of course that's not the main reason. It is because why we use this method is because it is slightly soluble in water. So that is why you can use this method. Okay, so this is how you can use the chemical that we are calling as being potassium, chlorate. Another chemical that we talked about that you can use is hydrogen peroxide. But I want to mention before I move on that in this experiment, the experiment is very explosive. So that is what you need to remember. The experiment is very explosive. So you need to take care in as much as you are carrying out, preparation of oxygen using potassium chloride. The last but not the least chemical that we can use is what we are calling as being hydrogen peroxide. So it is possible you can also prepare oxygen using hydrogen peroxide. So how is this carried out using hydrogen peroxide? Again, you are going to use a catalyst, and the catalyst that we use, manganese 4 oxide, is actually the best catalyst again that we use in the preparation of oxygen using hydrogen peroxide. So a hydrogen peroxide solution is actually reacted with manganese oxide as a catalyst. In this reaction, no heating is required. So no heating is required. That is what you need to remember. So what is going to happen is that the hydrogen peroxide there, which is in aqueous form, when treated with a catalyst manganese 4 oxide, you are going to find that it will break down into H2O and oxygen. So remember, the H2O is in liquid form, the oxygen is in gaseous form, and therefore you can balance up that by putting up a 2 there and also putting up a 2 there. So you can see the catalyst that we use in this case to help in the breakdown of hydrogen peroxide again is simply manganese. So manganese 4 oxide. So manganese 4 oxide is a catalyst that is used. Okay, so now a simple apparatus that I may give you that you can use, maybe we can try to draw up a very simple apparatus there that we can use. Of course, we can have our method of collecting the gas in that direction. So the method of collecting the gas in that direction. Okay. I hope it's making sense. I'm just trying to quickly illustrate what should be done or what you're supposed to know. That is still representing our gas jar. Okay, so that is a liquid, and the liquid that we have there is the water. Remember, the whole of this that you have there, that is the trough, and this there is representing the gas jar. So that is representing the gas jar. Okay, so that is what we have. Then in this direction, we can just increase the mouth of this round bottom flask. So we can also have a Thistle funnel in that direction. So we can have a Thistle funnel, and okay, we should draw properly that one. Okay, so this is just for the purpose of trying to, to illustrate for you, and that is why I'm actually putting it in that way. Of course, we can make sure that we seal up there with a gas stopper so that the gas, whatever gas is collected, does not come out. So this guy is what we call as being the Thistle. So this is the Thistle funnel, and the Thistle funnel is going to hold the solution that we are calling as being hydrogen peroxide. So that will be the chemical in there. Then inside there you are going to have maybe something that is going to be there, and that something there is a catalyst we are calling as being manganese 4 oxide. So that is manganese 4 oxide. That is what you are going to have there. So of course, when the hydrogen peroxide comes in contact with the manganese oxide, it will help to break down the hydrogen peroxide into water and oxygen. So the water will be formed, but the gas is going to rise and it is going to be collected there. So the gas that is going to be collected in there is what we are calling as being oxygen. So what is this method of collecting the gas that we are using? So the method of collecting the gas that we are using is what we call as being downward displacement of water. So initially the whole of this jar will be filled with water, but as the gas is being collected, the water will start will be pushed downward, and the gas will be collected over water. So that is what you need to remember. So a few concepts that you need to know during the preparation of hydrogen is that oxygen is collected over water. So that is what oxygen is collected over water. So in terms of the method of collection, we can talk about maybe the method of collection. So this method of collecting oxygen is what we call as being the downward. So we call it as being the downward displacement. So we call it as being the downward displacement of water. So water is being displaced downward, so we call it as being downward displacement of water. Then we can also use a drying agent. Remember, a drying agent is simply a substance. It could be a chemical substance that is used to dry up a particular gas. So in the case of oxygen, the best drying agent that you can use is concentrated. So you can use concentrated sulfuric acid. So you can use concentrated sulfuric acid. Let me just clear my space there because some people may not know what that is. So we use concentrated sulfuric acid. So that's the drying agent that we use. So the drying agent that we use is concentrated sulfuric acid. And basically, this is what you need to know in the exam. So once you know the 3 chemicals that we have talked about, using hydrogen peroxide, using potassium perchlorate, you can also use potassium nitrate or sodium nitrate. Those are chemicals. Remember, when it comes to hydrogen peroxide and potassium perchlorate, you need a catalyst which we call manganese 4 oxide. And in the case of potassium perchlorate, we said heating is required, but hydrogen peroxide, no heating is required. Let me show you a sample question of what you need to do there in the exam. So this is an examination question, that came in the ECZ exam, Examination Council of Zambia exam. And notice what it says. It says the diagram below shows the setup of the apparatus that would be used to prepare gas X. So they're talking about gas X. Have you seen what they use? Hydrogen peroxide and manganese, 4 oxide. So this is what they have used. So if you look at it, the gas is actually collected. Definitely you know what is the gas that is actually collected. And the question there says that identify. So A1 there says identify gas X. So in this case, gas X, we know that is oxygen. So that is oxygen gas. So that is what we mean. Then 2, it says describe the chemical test for gas X. So what is the chemical test, in other words, for oxygen? Well, you need to remember that the chemical test for oxygen is that oxygen, oxygen gas relights. It actually relights, a glowing. It actually relights a glowing sprint. That is what you need to remember when it comes to the chemical test of oxygen. So it relights a glowing sprint. So you get a test tube, collect the gas. When you introduce, more like you introduce a splint that is almost like an ember, you are going to see that it is going to be relighted. So that is what is going to happen. So oxygen gas relights a glowing sprint, introduced, we can simply say introduced in a test tube. So that is what it does there. Let's move on to the B part. I hope we are together. Let's move on to the B part. B1 there says, what is the purpose of adding manganese 4 oxide to hydrogen peroxide? Yeah, so we can simply say that it acts, as a catalyst. It acts as a catalyst, it acts as a catalyst to help, decompose, to help decompose, the hydrogen peroxide. So in other words, you can say it just acts as a catalyst peroxide to decompose the hydrogen peroxide. So it acts as a catalyst. That's the key word that you need to remember. Okay, so again, we can look at B2. It says, explain why this gas is obtained using the method shown in the diagram. So why do we use the method shown in the diagram? So we can simply say it is slightly, so it is slightly soluble in water. In other words, much of it is not going to be dissolving, just a small amount. So it's slightly soluble in water. No wonder we can use this method, collecting it over water, the downward displacement of water. Well, thank you so much. Watch out for maybe another video as I show you the industrial way of preparing, oxygen gas. So there's also an industrial way of preparing oxygen gas.